Somewhere in the constellation Boötes, there's a hole in the universe so large that if our entire Milky Way galaxy sat at its center and we pointed our best telescopes in every direction, we might not see another galaxy for millions of years of travel at the speed of light. Astronomers found it in 1981, and their first reaction wasn't excitement. It was disbelief. They kept checking their data, certain they'd made a mistake, because nothing that big was supposed to be that empty. They named it the Boötes Void. Some call it the Great Nothing. And decades later, scientists still don't fully agree on how something this vast, this hollow, could have formed in a universe that's supposed to be woven together by gravity into a vast connected cosmic web. Here's the part that should genuinely unsettle you. If a civilization had evolved on a planet drifting somewhere near the center of this void, and they built their own telescopes and looked up at their night sky, they might conclude they were completely alone in the universe. Not because they were wrong, but because there would be almost nothing else visible for them to find. Tonight, we're going into the emptiest place we've ever discovered. And we're going to find out why that emptiness still troubles the people who study it most. Let's start with what the Boötes Void actually is, because the scale of it is almost impossible to hold in your mind. The void sits roughly 700 million light-years from Earth, in the direction of the constellation Boötes, and it spans an estimated 330 million light-years across. To put that into some kind of perspective, our entire Milky Way galaxy is about 100,000 light-years wide. That means you could line up more than 3,000 Milky Ways, end to end, and still not cross this void. And inside that staggering volume of space, there is almost nothing. When astronomer Robert Kirshner and his colleagues first mapped this region in 1981 while surveying the distribution of galaxies in the universe, they expected to find hundreds, maybe thousands, of galaxies scattered through that volume of space, the way they do everywhere else they look. Instead, they found around 60. Compare that to what you'd typically expect in a region of that size, based on the average density of galaxies elsewhere in the observable universe, and the numbers stop making sense. Regions of comparable size elsewhere in the cosmos can contain tens of thousands of galaxies. Kirshner reportedly joked, in a moment that's become famous in astronomy circles, that if you were sitting in the middle of the Boötes Void with a good telescope, you wouldn't have discovered that other galaxies existed until relatively recently in the history of astronomy, because there would simply be so little around you to see. Let that settle for a second. An entire hypothetical civilization, potentially unaware that galaxies beyond their own even existed, simply because of where they happened to be born in the universe. That's not science fiction. That's a real, sober observation made by the very scientists who discovered this place. So the first question is obvious. In a universe where gravity is constantly pulling matter together, clumping gas into stars, stars into galaxies, and galaxies into vast clusters and superclusters, how does a gap this enormous simply open up and stay empty? To answer that, we need to zoom out and talk about the actual structure of the universe. Because most people picture the cosmos as a random scattering of galaxies, like static on an old television. It isn't. Over the past several decades, large-scale surveys mapping the position of hundreds of thousands of galaxies have revealed something far stranger and more beautiful. The universe is organized into what scientists call the cosmic web. Picture a sponge or a mass of soap bubbles pressed together. Galaxies aren't scattered randomly through space. They're arranged along enormous filaments and sheets of matter, stretching for hundreds of millions of light-years, connecting at dense nodes where massive galaxy clusters form. And in between those filaments, in the spaces equivalent to the empty pockets inside that sponge, you get voids. Vast regions where matter is far less dense, where galaxies are rare, and where the gravitational threads connecting the rest of the universe simply don't reach as strongly. Voids, on their own, aren't actually mysterious. Scientists have mapped thousands of them throughout the observable universe. They're a completely expected, well-understood consequence of how gravity acted on tiny density fluctuations in the early universe, amplifying small differences over billions of years until some regions grew dense with galaxies and others were left comparatively hollow. So why does the Boötes Void get its own reputation? Why does this one specific void unsettle astronomers more than the thousands of other voids we've cataloged? Because it's not just big. It's disproportionately, almost defiantly big. One of the largest voids ever confirmed, sitting dramatically outside the range that current models of cosmic structure formation comfortably predict. Here's where the real tension starts. Our best model of how the universe evolved, built on dark matter, dark energy, and gravity slowly assembling structure over roughly 13.8 billion years, makes fairly specific predictions about how large a void should be able to grow, given the amount of time the universe has had and the density of matter available to form structure in the first place. Voids should exist. They should even get quite large. But the Boötes Void pushes right up against, and by some calculations exceeds, the upper boundary of what standard structure formation models comfortably explain. It's a little like predicting the tallest wave you'd ever see on a particular ocean based on wind patterns and water depth, and then, one day, finding a wave that's not just tall, but sitting right at the edge of what your entire model says should even be physically possible. That doesn't mean the model is broken. Voids of significant size have since been found elsewhere, and refined simulations, incorporating dark energy's accelerating effect on cosmic expansion, have narrowed the gap between prediction and observation considerably since the 1980s. But when the Boötes Void was first discovered, it was large enough and empty enough to make cosmologists seriously question whether something was missing from their understanding of how structure in the universe actually forms. And that uncertainty hasn't fully gone away. It's just gotten quieter. Let's talk about what's actually inside this void, because empty doesn't mean what you might think it means. The Boötes Void isn't a perfect vacuum. It isn't a hole punched clean through space with absolutely nothing inside. Later, more detailed surveys conducted with improved telescope technology found additional faint galaxies inside the void that earlier surveys had simply missed, pushing the galaxy count up from the original estimate of around 60 to several dozen more. Scientists now believe the void isn't perfectly hollow so much as dramatically underpopulated, home to a sparse scattering of galaxies rather than a complete absence of them. But here's the detail that keeps this place feeling genuinely eerie rather than just statistically interesting. Even accounting for those additional discoveries, the region remains extraordinarily underdense compared to its surroundings, estimated to contain roughly a tenth of the galaxy density you'd expect to find in a typical, average patch of the universe of similar size. It's not a total void. It's something almost more unsettling. A region where the universe simply decided, for reasons still not entirely settled, to build far less than it did almost everywhere else. And there's an important, sobering scientific detail buried inside this discovery too, one that connects the Boötes Void to a mystery we still haven't solved anywhere in the universe. Every model attempting to explain how voids like this form or persist depends heavily on dark matter, the invisible substance that makes up roughly 85% of all matter in the cosmos. We've never directly detected a single particle of dark matter. We only know it exists because of its gravitational fingerprints, the way it bends light, and the way it appears to be gluing galaxies and galaxy clusters together far more tightly than their visible matter alone could explain. Voids are essentially the photographic negative of that same phenomenon. If dark matter is what pulls matter together to build the dense filaments and clusters of the cosmic web, then voids are what's left over in the places where that invisible scaffolding was thinner, weaker, or less present to begin with. Which means understanding exactly why the Boötes Void grew as large as it did isn't just a question about one strange patch of sky. It's tangled up directly with one of the biggest open mysteries in all of physics: what dark matter actually is, and how exactly its distribution shaped the structure of everything we see. We are, in a very real sense, using an empty patch of space to try to understand an invisible substance we've never directly touched or seen. Now, here's where the story shifts from genuinely strange to something that starts to feel almost personal. Remember that hypothetical civilization we mentioned earlier, the one that might have evolved somewhere near the heart of the void, unaware that other galaxies even existed. That thought experiment isn't just a fun bit of trivia. It's a serious illustration of something cosmologists call the cosmic horizon problem, and it applies in a smaller and less extreme way to all of us, everywhere in the universe. The universe is expanding, and that expansion means that, given enough time, galaxies far enough away from each other will eventually be moving apart faster than light itself can cross the growing gap between them. Once that happens, their light can never reach us again. They don't disappear. They simply become permanently, physically unreachable beyond the cosmic horizon, forever. A civilization evolving deep inside a void like Boötes would experience an amplified version of that isolation far earlier than a civilization evolving in a denser part of the universe simply because their nearest galactic neighbors are already so much farther away to begin with. Their night sky would be sparse. Their understanding of the scale of the cosmos, if they ever developed astronomy at all, would likely take dramatically longer to unfold, if it unfolded at all, purely as an accident of cosmic geography. It raises a genuinely unsettling question that some cosmologists have taken quite seriously in academic discussions about our own universe's long-term future. As the universe continues expanding, and it does so at an accelerating rate due to the effects of dark energy, more and more galaxies will eventually cross beyond our own cosmic horizon. Billions of years from now, an advanced civilization looking up from a planet orbiting a still existing star might see nothing at all beyond its own galaxy. A sky as sparse and lonely as the one we're imagining for a hypothetical observer inside the Boötes Void today. In other words, the Boötes Void might not just be a strange anomaly sitting out there, distant and unrelated to us. It might be an early preview, a glimpse of what our own corner of the universe could eventually resemble in an unimaginably distant future. Once cosmic expansion has carried enough of our galactic neighbors permanently out of view, that's the moment this stops being a curiosity and starts being something closer to a warning. Let's bring this back to what astronomers actually think is happening, because it's important to separate the solid science from the more speculative edges of this mystery. The mainstream, well-supported explanation for the Boötes Void's existence isn't exotic or alarming at all. It's the standard story of cosmic structure formation, just taken to an unusually extreme outcome. In the earliest moments after the Big Bang, the universe wasn't perfectly uniform. Tiny quantum fluctuations left slightly denser and slightly sparser regions scattered throughout the primordial soup of matter and energy. Over billions of years, gravity amplified those differences. Denser regions attracted more matter, forming the galaxies, clusters, and filaments of today's cosmic web. Sparser regions fell further and further behind, their weaker gravity unable to pull in much surrounding material, leaving them comparatively hollow as everything around them grew more crowded. Under this explanation, the Boötes Void isn't broken physics. It's simply a statistically rare, unusually dramatic outcome of a process that happens everywhere in the universe, the cosmic equivalent of a fair coin landing on the same side an improbable number of times in a row. Rare, striking, worth studying closely, but not evidence that something is fundamentally wrong with our understanding of the cosmos. That said, and this is where honesty about the frontier of science matters, some researchers have pointed out that the existence of voids this large, this early in cosmic history, does place real, meaningful pressure on the finer details of our structure formation models. It's one of several data points cosmologists use to test and refine our understanding of dark matter's behavior and dark energy's influence on the growth of cosmic structure over time. It's not proof that something is broken, but it's not nothing either. It's one of the puzzle pieces that keeps this field of science honestly, actively unsettled at the edges. So maybe the void doesn't terrify astronomers, because they think something sinister is lurking inside it. Nothing about the void itself is dangerous to us. In any physical sense, it poses no threat, and it's far too distant to have any conceivable effect on our solar system. What actually unsettles the people who study it is something quieter, and in some ways stranger, than any danger. It's the reminder, sitting there in plain view, spanning hundreds of millions of light years, that the universe is capable of building structures so vast and so imbalanced that they push right up against the outer edges of what our best theories say should even be possible. It's a standing challenge, hovering in the constellation Boötes, daring cosmologists to make sure their models are actually complete. And there's something quietly humbling, even beautiful, buried inside that unease. Every void, every filament, every dense cluster of galaxies woven through the cosmic web tells part of the same origin story, the story of how impossibly tiny differences in the density of the early universe, differences smaller than you could ever meaningfully picture, eventually grew over billions of years into the largest structures humanity has ever mapped. The Boötes Void isn't separate from that story. It's the same story, just written in negative space. Not where matter gathered, but where it didn't. Not the presence of structure, but its glaring, deliberate absence. In a strange way, understanding why nothing is there might end up teaching us just as much about the universe as understanding why everything else is. So here's the truth we're left with tonight. Somewhere out there, 700 million light years away, there's a region of space nearly 1,000 times larger than our own galaxy, holding only a scattering of galaxies where tens of thousands should statistically exist. It isn't a hole torn through reality. It isn't dangerous, and it isn't coming for us. But it is a genuine, unresolved reminder that even our best model of how the universe built itself has soft edges, places where the numbers stretch further than anyone expected, places where the void itself becomes the evidence. And maybe that's the most unsettling thought of all, not that the Boötes Void is empty, but that its emptiness might be a quiet preview of where the rest of the universe is slowly, patiently heading, a future where the night sky, for everyone, everywhere, eventually grows a little more silent, a little more alone. For now, though, we still have a sky full of galaxies. We still have a universe dense enough, connected enough, to have produced telescopes capable of finding a hole this large in the first place, and minds curious enough to wonder what it means. The Boötes Void has been sitting out there patient and hollow for hundreds of millions of years, and for now, at least, we're still close enough and early enough to be the ones asking why.